Every star you see messages from the past. Have you ever stood beneath a clear, dark sky, far from the glow of city lights, and felt a profound sense of wonder? As you gaze upwards, you're not just seeing a static display of twinkling lights. You are, in fact, receiving ancient messages, whispered across the vast, silent expanse of the cosmos. Every single star you see is a time capsule, a snapshot of a moment long since past. This simple yet staggering realization connects us to the universe in the most intimate way imaginable. It transforms a simple act of stargazing into an act of time travel, where your eyes become the destination for photons that have journeyed for years, centuries, or even millennia. Think about that for a moment. The faint light from a distant star that finally reaches your retina tonight might have begun its epic journey before you were even born. It could have left its stellar home while your grandparents were children, or even when great empires rose and fell here on Earth. This light is a silent witness to history, both cosmic and human, and its arrival is the final chapter in a story that has been unfolding for an unimaginable stretch of time. To grapple with these immense cosmic distances, we needed a new kind of ruler. This is the astonishing idea behind the light year. It's a common misconception that a light year is a unit of time, but it is, in fact, a measure of distance. It's the distance that a beam of light, the fastest thing in the universe, travels in a single Earth year. That distance is an almost incomprehensible 9.46 trillion kilometers, or about 5.88 trillion miles. It's a number so large that it almost loses its meaning, a testament to the sheer scale of the stage on which the universe plays out. At this scale, our familiar terrestrial measurements like kilometers or miles become utterly impractical. Using them to describe the gap between stars would be like measuring the distance between London and New York in millimeters. The numbers would be so astronomically large and unwieldy that they would obscure, rather than clarify, the true layout of our cosmic neighborhood. The light year provides an elegant solution, a yardstick perfectly suited for the grand architecture of space. The light year does more than just measure distance. It reveals a deep and fundamental truth about our perception of the universe. Because light travels at a finite, though incredible, speed, nothing we see is ever truly live. There is always a delay. Every observation, every telescopic image, is a glimpse into the past. The farther away we look, the deeper back in time we see. We are cosmic archaeologists, sifting through layers of ancient light to piece together the history of everything. Even our closest stellar neighbor tells this story. The nearest star system to our own sun is Alpha Centauri, and its faintest member, Proxima Centauri, is about 4.24 light years away. This means the light we see from it tonight left that star over 4 years ago. If Proxima Centauri were to suddenly vanish, we wouldn't know about it until more than 4 years from now. We are always seeing our celestial neighbors as they were, not as they are. And when we turn our most powerful telescopes to the darkest patches of sky, this effect becomes truly mind-bending. We see faraway galaxies not as they are today, but as they were billions of years ago, when their light first began its journey towards us. We are literally looking back into the ancient history of the cosmos, witnessing the universe in its youth. These faint, ghostly images are our only direct window into the cosmic dawn, allowing us to piece together the grand narrative of how everything we know came to be. These unfathomable distances don't just inspire awe, they present profound, practical barriers. They explain why interstellar travel and communication are so challenging, perhaps even impossible with our current technology. The sheer scale of the cosmos forces us to confront the fundamental limits of physics and engineering. Consider physical travel. Our fastest spacecraft, like the Parker Solar Probe, can achieve incredible speeds relative to us, but they are cosmically slow. even traveling at over 400,000 miles per hour. Such a probe would need more than 6,000 years to reach Proxima Centauri, our nearest stellar neighbor. The Voyager probes, which have been traveling for decades, would take over 75,000 years to cover the same distance. The energy required to accelerate a significant payload to even a fraction of light speed is staggering, far beyond anything we can currently generate. Communication faces a similar, insurmountable hurdle: the speed of light. While it is the universe's ultimate speed limit, it is frustratingly slow on an interstellar stage. Messages sent to any potential future colony around another star would take years, or even decades, just to arrive. A reply would take just as long to return. This means a simple exchange of, "Hello, how are you?" and "I'm fine, thanks," could span a human lifetime. Real-time conversation across the stars, the kind we take for granted on Earth, simply cannot exist. It is a physical impossibility. This cosmic latency has profound implications for our search for others. Even if intelligent civilizations are common, they may be so far away that their signals haven't reached us yet, or ours haven't reached them. We might be listening to a silent cosmos, not because it's empty, but because we are separated by an ocean of time as well as space. To truly grasp the power of the light year, we must zoom out from our stellar neighborhood and consider the grand architecture of the cosmos. Our journey begins at home, in the Milky Way galaxy. This sprawling spiral city of stars stretches about 100,000 light-years from one edge to the other. It's a staggering distance, one that light itself takes 100 millennia to cross. Within this structure, our sun is just one of at least 200 billion stars, each a potential sun for other worlds, all held together by the gravitational pull of a supermassive black hole at the galactic center. But our galaxy isn't alone. It belongs to a small cluster of about 80 galaxies known as the Local Group. Our nearest major galactic neighbor, the Andromeda Galaxy, is about 2.5 million light-years away. When we look at Andromeda through a telescope, we are seeing light that began its journey when early human ancestors were first walking the Earth. This cosmic neighborhood, the Local Group, spans roughly 10 million light-years. And the Local Group is just one tiny node in a far grander structure. Beyond it lie trillions of other galaxies, arranged not randomly, but in a vast, web-like pattern of filaments and voids. This cosmic web makes up the observable universe, a sphere of space centered on us, with a diameter of about 93 billion light-years. This is the limit of what we can ever see, the boundary defined by the age of the universe and the speed of light. Yet, this cosmic horizon is not static. The very fabric of space is expanding, carrying galaxies away from us like raisins in a rising loaf of bread. The farther a galaxy is, the faster it appears to recede. Eventually, the most distant galaxies will be carried away by this expansion faster than their light can travel toward us. They will cross a cosmic event horizon, their light forever unable to reach Earth. Some of that universe is disappearing from our view, forever. And yet, from our tiny, fragile planet, a pale blue dot in the vast darkness, we have managed to comprehend this scale. Through ingenuity and relentless curiosity, we have developed the tools and theories to measure these unimaginable distances. The light year is more than a unit of measurement. It is a testament to the power of the human mind. It reminds us that while we may be physically small, our capacity for understanding is boundless. Our intelligence allows us to explore a universe far larger than anything we can personally experience. Every point of light in the night sky is a message from the past, a connection across the immense gulfs of space and time. Contemplating these cosmic distances doesn't diminish us. It elevates us. It solidifies our role as observers, thinkers, and explorers of the unknown, forever looking up and seeking to understand our place within this grand, silent, and beautiful cosmos.